Finding zeros of a polynomial function is equivalent to solving an equation f of x equals 0, and it is often not easy to do so when the degree of the polynomial is more than 2. Rational zeros theorem offers some help with this task. It says that if you have a polynomial with integer coefficients, polynomial that has a degree greater than 0, then P over Q is a rational zero if P divides A sub 0 and Q divides A sub n. Now, by a rational zero, we mean a zero of the function that is a rational number. That is, it is the quotient of two integers. So if I'm writing P over Q, the understanding is that P is an integer and Q is also an integer. Simply stated, the theorem says that any rational zero of a polynomial with integer coefficients must be of the form factor of A sub 0 of the factor of A sub n. So this is my P over Q. So if I have the example and I want to find potential zeros of the polynomial, then I have to identify A sub 0. And this is the term without x in it, so A sub 0 here is 6. And I have to identify A sub n, which is the leading coefficient, and in this case it is negative 4. Then any rational zero is going to be of the form P over Q, which is the factor of A sub 0, which is the factor of 6, divided by factor of A sub n, which is negative 4. So let's list the factors of 6. That's going to be numbers plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Factors of negative 4 are plus or minus 1, plus or minus 2, and plus or minus 4. Any rational zero will have one of the numbers plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6 in the numerator, and any of the numbers plus or minus 1, plus or minus 2, and plus or minus 4 in the denominator. So let's list all those numbers. If I choose plus or minus 1 in the denominator, then I will obtain the following numbers: plus or minus 1, plus or minus 2. Now plus or minus 3 divided by plus or minus 1 is going to be plus or minus 3, and plus or minus 6 divided by plus or minus 1 is going to be plus or minus 6. Now, if I choose plus or minus 2 in the denominator, my numbers are going to be plus or minus 1 over 2. Plus or minus, I will take 2 from the numerator, and 2 is in the denominator. Then plus or minus 3 from the numerator, and the 2 from the denominator. And plus or minus 6 over 2. Now, if I choose plus or minus 4 from the denominator, my numbers are going to be plus or minus 1/4, plus or minus 2/4, plus or minus 3/4, and plus or minus 6/4. If you look at those numbers, some of them are going to repeat. For example, 2 over 2 is 1, 6 over 2 is 3, 2 over 4 is 1/2, it's already present, and 3 over 4 is 3 over 4, it's not present there, but 6 over 4 is simply 3 over 2, so we are not going to rewrite it again. And therefore, we can now write complete list of the possible zeros: plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 1/2, plus or minus 3/2, plus or minus 1/4, and plus or minus 3/4. Any one of those numbers could be a zero of the polynomial f of x.